Today we are going to see how to plot data using Matlab. Matlab is very powerful when it comes to visualization and plotting of data. So we have these functions here today, which includes plot, x label, y label, x limit, y limit, title, legend, whole, and GCA and grid. So these are the features that Matlab provides us to plot data. So we will see how we can use them effectively to plot our data and present our outputs. So let me begin with generating input data. So I'm going to use this commands that I've typed here. Okay. So I'm going to generate an input data. So for that I'm going to use a function called as linear spaced function in Matlab. So basically what it does is, I'm just going to comment this, I'm just going to uncomment, and let me just run this and show you. So if you see here, the graph data is nothing but values from 0 to 10, and that's what the colon operator helps me to do. It's values from 0 to 10, so I get 11 values, and then because including 0 and 10. So this is what I get with graph data. So now if I go let it be there, then I can comment this, and then let me give this value 0 to 10 and 10. So I get pretty much the same output. Okay, so between 0 to 10, sorry, it's 0 to, yeah, I need 11 values, sorry, 11 values, not 10 values. So you can see that I get pretty much the same. So this is what a linear space does. It just linearly space. So linearly space means the difference between the values is always the same. So it linearly spaces the values, because here it's 2 minus 1, 3 minus 2, 4 minus 3. And if the range is different, that spacing, the difference will change. It will not be always 1. In this case it's 1. In some case it may be different. So depending on the range of values, we use this linear spacing. Suppose we want to generate more values. So I was generating 100 values. Then it's quick, it's easy, because it's with here also you can do the same thing, but I would still prefer this function, and it will do this. But here the difference is just 0.1, 0.1, 0.1. Before it was 1, and when you scale it to 100 times, it becomes 0.1. So this is the linspace function that we are using for our input data generation. And what I'm going to do is, I'm taking this is my plot 1 data, I'm calling it as P1. I'm just applying a trigonometric function sine to that data. And for my P2, I'm taking cos. So we are going to plot this sine graph and cos graph, because that is visually more differentiable, and it is also easier to look at. So we will just use these trigonometric graphs for plotting our data. So now let's get to the plotting part. So I'm going to plot these graphs. So the functions that I'm going to be using today are the basic plot functions. So the plot function syntax is the x-axis. So x-axis is my graph data that I've just generated with linspace. Then I have my y-axis, which is going to be my P1 and P2. And I'm using this figure to initialize a new figure. So if let us see what if I don't. Let me just do this. Wow. So I see two graphs on my screen. I see a sine wave and I see a cos wave. Okay, so the first graph is a sine wave and the second graph is a cos wave. You see there is a difference. One starts from 0, the other one starts from 1. Now, why do we need this figure? So let me just say that I don't have this figure here. So you don't initialize a figure for the cosine graph, and just run this and see what happens. Here you still see that you get two graphs. Okay, because you have initialized a figure, and then so let us do this also, and then you see what happens. You get two graphs, but this is not normally the case, because I'm using an editor which supports different outputs for different plot. But when you disable this figure, what happens is it normally overwrites. At times it overwrites the graphs. So when I do this, and if I don't have this figure, it just writes, it just draws on top of this figure. So that is why we need to initialize this new figure, just to be on the safe side. We initialize every plot with a figure. Okay, so that is the basic plot. Now let's see what other things can we do with this. So I was going to say this, we can label the graph, right? So that was the next thing. So we can label the graph, and we are going to label the graph in this manner. So we can give a title to our graph. We can create an X label and a Y label. Pretty straightforward. So now our graph looks more informative. So it says that the title of the graph is trigonometric plot, and my X label is time axis and my Y label is the sine values. So that is one feature that we can add. And the next feature that we could add here is changing the axis limit. So you can change the axis limit in your Matlab, and you have the function called as x limit and y limit. So we will see what this x limit and y limit does. So you take the figure, you plot it. Okay, so we have plotted it and we have given the label. So till here it is the same. And now here comes my x limit. So I can change the range of my x-axis and y-axis, right? So I can change the range of my x-axis and y-axis, and that is exactly what I'm going to do here. I'm going to keep my x range from 0 to 5. So if you see on this graph, the x range is from 0 to 10. So I'm going to keep it from 0 to 5. And then for my y limit, I'm going to keep the range from 0 to 1. So it is here from -1 to 1, and I'm going to keep it from 0 to 1. So let us do that first and see what happens. Yeah, now the range is converted. Before it was from 0 to 10. Now I have it from 0 to 5. And here I have it from 0 to 1. So it's a very useful feature when you don't want your graph to look very very in a range which you don't prefer, and you want to zoom in on a graph, or you want to only display a specific window in your graph. You can use this xlim and ylim. And then we have this legend, and pretty much what it does is it just says something about the graph. So we know that this is a sine wave. Or you may have a title. You can you can, each graph can have a title, say like it's so this title can be, let us say, plot 1. So that is what we have given, P1, plot 1 and P1. So I give it some title for my graph, and then if I plot it, then I get that this is the title of the graph. So the legend can be useful in giving titles or giving some information about the graph when you have, this is pretty much needed when you have multiple graphs on your plot. So when you have 2 to 3 graphs, which is what we are going to see next, it is always useful to keep this legend so that people have an idea on what each graph represents. Now let's come to the next topic, and this is the plotting multiple graphs in the same figure. So how do I do that? The simplest way for me to do this is using a command in Matlab which is called as hold on and hold off. So this command is a very powerful command. So it tells my command to hold on to the graph, right? So I told you that if we don't initialize with the figure, it's going to overwrite. So here I have not created a new figure. Here what I want is, I want it to overwrite, right? When we have a figure initializing the graph, it doesn't overwrite. But if you want it to overwrite, you use this command which is called as the hold on and hold off. So here it tells Matlab to hold on to that graph, just hold on that axis. I want to draw another graph on that same axis. So Matlab says, okay, I'm holding it on. You bring the next graph, and it plots the next graph on the same figure. So let's see what happens here. You can see the two graphs. So because I've given x limit and y limit, so you see a zoomed up version of the graph. Otherwise, you see the full version of this graph. All right. So you use the hold on, but you have to make sure that you give a hold off when you tell Matlab, okay, fine, I have drawn all my graphs. Now you don't have to keep holding my axis for me. You can keep it off. So that will indicate Matlab that, okay, the drawing has happened. The multiple graphs have been plotted. Now I don't have to hold on to the axis anymore. So you have to always make sure that you put this hold off. Else what happens is the next graph, even if you want to plot it on the new figure and you don't have a figure option, then it kind of messes things up. You see a lot of other things on your graph showing up if you don't use this hold off at the right place. So use hold on to initialize the multiple plotting, and once you're done plotting all the graphs, use hold off to just make sure that this graph plotting is done and it is closed. Next is the graph appearance. So what we want to tell here is now a little bit about the appearance of the graph. So changing the graph appearance. So what we will see is, by default, Matlab gives few things for your graph, right? So Matlab lets you plot a few things, but you may, if you want to feel like, you feel like you want customization option, you want to change some things that Matlab is, it doesn't look good, this coloring and other things, you have the option to change, and that is with the help of line spec. The line spec is a feature in Matlab that allows you to change the line type, the color and the marker shape. So the syntax is in this manner. So you give a dash, so that is your line type. So you tell that my line type is a dash, it's just a line. Then you have a B, this is the color, it's a blue color. So you have different colors, blue, red, pretty much the primary colors are available: blue, red, and orange. What is it? Blue, red, and green. So these are available. Orange is also available because I'm seeing orange on the screen and I say that one. Then you have a marker shape. So marker shape, you have different shapes. You have a star shape, you have a square shape, you have a dot shape, you have a diamond shape. So you have all this. You can just refer, you just go to Matlab help and just type this line spec. If you type it line spec, you will see what are the options you have. So here I'm using some of that. So I'm using a dash line. So when I do two line, it says it's a dash line. I'm using a blue color and then I'm using a dot marker. Here I'm using a dash line, I'm using a red color, and I'm using a square marker. Now let us see how my graph is going to look. Yeah, it's looking much, I wouldn't say better, but yeah, it's looking more bright, it's looking more colorful than it was previously. So this is the basic thing that you can do. You have other options also to customize. So that is, now what you can do here is the line width and marker size. So if I say this, what happens is, if you see this graph, I feel like the marker size is a bit too much, or it's a bit small. Then I want to change the marker size and the line width. So these are two common things that I can do, because to the line spec which is having line shape and the marker shape, I can give this size. So I can change the size. So let us look at how this line width and marker width makes my graph. So you can see that this is much more neat. So I have reduced the marker size and reduce the line width. It's looking a little bit bold, but it is better than the previous one where the markers were a little too large, and that was by the default Matlab setting. So at times you may have to use the custom settings to make the graph look more appealing, and then if I just give these other features also, then your graph looks pretty good at this stage. So this is with the customization option you have in Matlab, and this is pretty pretty handy when I tell you are working on any projects, you're working on any kind of academic industry, anywhere you want to display the outputs, you want to display your results, you have this feature in Matlab that helps you to display it in and customize it in any way you want. And so this is a very useful feature in Matlab. Next, what we are going to see is we are going to see how we can plot the graph, placing the graph side by side. So what I am going to do is I'm plotting. I told you hold on and hold off is used for plotting multiple graphs on the same window. Now, what if I want to plot it side by side? Right, when I use a figure, it creates a new figure, and every time you're plotting it on a new figure. But what if I want to plot it side by side on the same figure so that I can do some comparative study? So I want to compare it. Because I don't want to use hold on and I don't want to use figure, but I want to use something else that will allow me to display it side by side and do the comparison for me to learn. So for that, what I'm having is figure. Okay, I'm having this subplot. Okay, I'm initializing with the figure, and then this is the syntax of my subplot. It says that you have a row plot, you have a column plot, and then you have plot index. So what it means is, what is the row size you want? What is the column size? So it's just telling the dimension of your subplot. Okay, when I say rather than row plot, I call it like row size and column size. It's a bit confusing. And then the plot index. So if I call this row size, this one, try to change it in a couple of places. Yeah, so this is pretty much the syntax, and let us see what it does. So I'll just uncomment it. Now I'm going to give, just before this plot, I'm going to give the subplot command, and I'm telling that you display the figure in a 2x1 fashion. So you display the figure in a 2 row and 1 column manner, and then the index is 1. So and then put the plot in the first position. So when I run this, you can see that. So you get a 2x1. So here you have 2 rows. So the first row and the second row. So the rows are the horizontal and the columns are the vertical. So if you don't know that, you have to know. So this is my row. Okay, so this is my row, and this is my column. The column is the vertical. So now I'm plotting it 2 rows and 1 column size. So let me just plot the other one also. This is my index 1 graph. So first graph. Then my second graph, I'm going to give the index 2, is going to be plotted in the second place. Okay, So this is my, I can plot it. I wanted to plot it side by side. So this is like, one beneath the other. So how do I do it side by side? Just a small change. I make it 1 row, 2 column. So when I do it as 1 row and 2 column and I run it, then I get it on a side by side. So this is much better. So now I can compare what is the size, I can compare what is the shape, I can do a lot of things onto this graph, and then I get this. Okay. Then I do this plot IDX equal to 1 and 2. I can change this. If I give this 2 and if I give this 1, you see the graphs get interchanged. Now it becomes, on the left side you have the red graph, and which is the cosine graph, and on the right side you have the sine graph. So subplot is a useful command for displaying your graphs on different scales. So if I keep it as a 2x2, so if I am keeping, so this means I can go up to 4 graphs. So the number of graph is defined by the product of this row size and column size. So I have this 2x2 means now I can display up to 4 graphs, but I have only 2 graphs. So it will display the 2 graphs, but it will keep the space for the other 2 space vacant. So I still can plot 2 more graphs. Right, so I can do that. I can just I'll just show one more graph, just the same graph, we'll plot it. So this is my 3rd position. Yeah, you get this graph, and I'll plot one in my 4th position. So this is my index 4. Okay, so this is my subplot feature. So it's very useful again for displaying the output the way you want it. So you have multiple inputs, and you have a couple of inputs you want to display, you have a couple of outputs you want to display. The best way to do it is using subplot. You may have to get around how to map the dimensions and how to give the indexing, but that once you get the hang of it, then it's a very easy way to display your outputs. Okay, then coming to one last thing for the plot is about GCA and grid. So this is something you may not need it much, but still it's good to know what is your get current access and what is your grid. So pretty much get current access allows you to get the access of that figure. So here I am plotting. Let me just plot this. So I have plotted this trigonometric plot, and now I've given the title X label and Y label. Now I'm going to take the property of that axis. So GCA means get current access. So that's what it says. GCA is get current access. So it will get the property of my current axis, and then I can change few things right from here. I can change the font size. So now what will happen is it will change the font size of the axis to 16. Now you see it is a bigger. So let me just plot it twice. One with the current axis, one without the current axis. Okay. Yeah. So this is without GCA GCA modifications. Okay. This is with GCA modifications. Okay, so now we can see the 2 graphs. What happens? We can clearly see this graph is having the font size to be smaller because I've kept the font size on purpose. I've kept the font size to be 16 for this graph, and I can even do the X limit and Y limit in this manner. So I can do the X limit and Y limit by taking the GCA. Okay, so I've taken the GCA, and then my GCA property is plot graph 1, and on this I can change my X limit and Y limit. So now I can see that my X limit and Y limit has changed from 0 to 5 and 0 to 1. This is very useful. Again, it is only needed when you want to change some properties outside, not immediately after plotting. So what happens is you plot the graph at the beginning of your code, then you have a couple of things, computation happening in your code, and after that you want to change your X limit based on those computation. So rather than again plotting, calling the plot and again giving the X lim and Y lim, you can just call this variable. So because this is now having the X axis property get current axis, but it has to be the current axis, right? If you plot any other graph after that, it may not be helpful. So you can just use this, but this is little bit on the medium level, not on the basic level. So I'll just say that this feature is there and this can be used. And the last one is grid on, and this will help you to display the graphs in a grid-like manner. So this will help you to measure. So what is this point? So what is this point on the x-axis? So this point is 0.61. So you can likewise you can you can measure the points on your x-axis. You can just use the data point also. It will give you the access point. You can see that, but this is in a much more presentable manner if you have the grid on option. All right, so that is for today's lecture. I hope this was clear to you. So practice, post your questions on the comment section, and let me know if the code is also updated for you guys on the GitHub. So please learn and have fun. Thank you.